Hello students, here I am back, and now I want to have it about surjective. Yeah, what does it mean? They call it also onto, and yeah, what is the case? You have some function, and that you have some domain, and you have some range, and the function is injective is surjective if every point of your range has an original. So so this function is surjective. If for every element out of that set R there is some x in D with the f of x equal to y. And here I say there is some and so that does not mean that there has only to be one. No, I say there has to be some value which gives you that y, and maybe there are more values than that. It doesn't matter me. It is no problem. Examples. Now, if you have, for instance, the function, if you fill in that you get the sine of x out of it, now then you can say to people, now that function goes from the real numbers to the interval with values between -1 and +1, and here you have here it is surjective. But if you have if there would have if there stood that you have that function f goes from, and then from -10 to 10, and you take also the same value, that same function, or take f of equal to the cosine of x or something like that, you did instead of the sine of x. Now then you can say to people from yeah, take y of let the function, I not take what, let f of x be the cosine of x. Now then you can say to people take y equal to 9, and then there is no solution. So there is no value of x which will give you that if you fill that in, that you get 9 out of it. You know the cosine of x in absolute values are less or equal to 1, and so you will never get 9 out of it. So this function here, f, is not surjective on that interval which is given here. Here there is given some interval there, -10, 10, and that f f is not surjective on that interval minus 10, 10. There are values out of that interval such that you have that you want, if you want to solve that equation, that you have no solution. So here you have two examples of functions. Here this one is surjective, no problems at all. But here you see the cosine of x. If you look to that that interval which is given here, that is of importance, and then you see not surjective. Therefore was in first instance what I told you not so quite well, because what if you take your if you have some function f, now some function has always some domain, and the domain of your function, and then if you take all values out of your domain and you calculate the function of f, you can calculate the range. And so you have in certain sense always that your function, if it goes from the domain to the range, that it is always surjective on the range. On the range of f. But that is because you have you take all values out of the domain, and that gives you the range, and that is in certain sense all the range of f that is the set of all values of fx where x is taken out of the domain of your function. Now, and so you have always a solution. Now, okay, and why are we now doing that? Now that is because of you saw the title of the chapter 3.2.1, and there was staying inverse function. And it goes about the word inverse. If you have some function f, it goes from some set d to some set b. Now, if f is injective, on d, and f is surjective on b, if that is the case, so you have that function f that is injective on the domain, surjective on that set b where the values become, then your function is is invertible. If that is the case, then f invertible so I invertible, yes, and that you can also write down the in f, the f inverse, that inverse function f, the inverse function of f exists. And that inverse function, you write function with that -1 here. And be careful in that I'm writing just directly here. This thing, there is not meant with it 1 divided by the f of x. So be very careful by reading books and other kinds of things. Look always from how they write inverse functions, but the inverse function is not the function 1 divided by the f of x. So important injectivity, surjectivity, and then your f is invertible, the inverse function exists. That inverse function, that has certain important things. That means that if you have your function, if you let it work on the inverse function, you will always get x out of it. And also the same way the other composition, if you let the inverse function work on f of x, you will get x out of it. That are the two important things of inverse functions. And yeah, what do you do? Now, or what if can I make some little bit explain to you from take some graph that I can let you see what is meant. Now, if you have, for instance, here the x-axis and the y-axis, and you have 0, and then let me look only for the positive values of x. That is for me a little bit easier to describe. Now then you can maybe you have here, you have the graph of your function f. So you have here some value x, and here you can calculate the function value of it. Now, and then if you also, here you have the line y is x, if you mirror that graph in that line y is x, and then really mirroring, so you put some mirror on the line y is x, and you look to the graph of it. Now then you can do the only things you have, in certain sense, you have to do is to change those coordinates. So you have, if you have here x and here the value f of x, and if you mirror it in the line y is x, you have only to change those the places of x and y, and so then you get out of it, you will get the fx x as a mirror point, and the graph you get at that moment, that is the graph of your inverse function. This y, that is the graph of the inverse function of f. So if you mirror the line y is fx in the line y is x, you get the graph of the inverse function of f. And that is of importance by mirroring it. Mirroring it mirror means changing the order of the coordinates in certain sense. Here you have the value fx, and here you have then the x, so you mirror those coordinates, and you have, or you change your coordinates, and if you can do that everywhere without any problem, you have the inverse function. Now, let me do now that for certain examples we have also just done, and then let me mirror it. Now, for instance, the first one, here you have the x-axis, there you have the y-axis, and we had that graph y is equal to x squared. Now, nice function, no problem. It is a function. If you fill in, if you have some x, you fill in, you get one value out of it, and that is no problem. Now, and now you can mirror it in the line y is x, and if you mirror that function, that you get the following. And what do you see? You have no function anymore. Because look, if you have then some value of x, I can choose out of two values, and I just told you functions are just where you are things, are operations where you just put one thing in and you get one thing out of it. Now, and here you see, if you mirror that graph of y is x squared, you get some other thing, but that is no function anymore. There is a problem. So you have here, so this one is not invertible. So this example, not invertible. So a problem. Okay. But then another one. And what did we do? For instance, the one where we only looked for negative values of x. This one here. Y is x squared. So now, and now maybe it is good to take the x-axis not so small but a little bit longer than that x-axis here. We have the line y is x, and now you can mirror that function. So if you take some x, you take some f of x, and you change those coordinates. Now what do you get out of it? You get this here out of it, and then not horizontally, it goes down and it keeps decreasing, but you are now mirroring that function. And here this one here, this looks like the minus the square root of, and then we have to be a little bit careful. The values are positive, so there's no problem. So this is minus the square root of x with the x only positive. And here you see that if you have that function here, the domain of our function that were only the values out of the real numbers where the x was less or equal to 0. That was our domain. On that domain our function is injective, no problem. Then the range of f that are only the positive numbers, so that are all values out of the all real values where the y is greater or equal to 0. And if you take that domain and that range, then that function is injective and surjective, and so it is injective. And so our f goes from that domain to its range, and you see injective and surjective. And you see your f is invertible. No problems. And here you see that, you see in this example, you see that you have some inverse function. In the case of both, your inverse function of x will become minus the square root of x. Now and look, if you let f work on that inverse function, what do you get? And you get minus the square root of x squared, and that gives you x back. And look well, our x yes. In this case here, the x is negative, yes. No, sorry, that is, no, I'm not, if you take the x is positive. But if I do the other way around, if I take my f of x and I let the inverse function work on it, then I have that inverse function I have to let work on the x squared, and if I take there what I have written down, then I get minus the square root of x squared, and so you get the minus x out of it. And in this case you see that your x is negative. Or I can better tell to you from the square root of x squared, if you take it, is always defined as the absolute value of x. And so what do I have here? In certain sense I have here that I get out of it minus the absolute value of x, and so I have some value which is smaller than 0. And that is also good. Look to the graph. You see that you are in the second quadrant. There you are. X is negative, and that has also been the case there. There is no problem. And maybe I have here I can better write down here only defined for x is positive, yes. But then yes, I have to be careful. If there is spoken about the square root of x, then all we have always in mind the following, that you have here the x-axis, there the y-axis, and then we have always this as y is the square root of x. This is for us the square root of x. that I'm using there also, and I see that I get also the nice values out of it, which I have to get. And you see that the inverse function you can only work, so you see that you have here some value of x, and then you get that value out of it which is below, which is negative. But you see that here your x is positive. But be careful. Now, and so we can, and now I have in some sense already done, maybe I had to do this one first before the other one, but okay, now I have done the other way around. Here we have y is x squared. Now you have the line y is x, mirror that function, and you have your inverse function, and that is the square root of x, and that was, I have just explained to you about how to go with it. And but be careful, and then you have for your domain of your f, you take only the positive numbers, so that are all the real numbers where the x is greater or equal to 0. That is your f, and your range. Now if you look to it, you see that you have also all values which are positive. Or maybe I can better write for you here all y's which are positive. And you are looking at the y-axis, and you have only the positive y's. And so if you take this domain and you look to that range to it, you see again that your function f is invertible. F is injective and surjective, and that means that f inverse exists. And so you see that it is very important to look to that domain and to that range. Very important. And a lot of it depends on those things.